All right, guys, so this is the problem that we kind of didn't get to finish on Monday. Fuel engineers use the extent of the change from carbon monoxide in water to carbon dioxide and hydrogen to regulate the proportions of synthetic fuel mixtures. If 0.250 moles of carbon monoxide and 0.250 moles of water gases, are placed in a 125 milliliter flask at 900 Kelvin, what is the composition of the equilibrium mixture? At this temperature, Kc is equal to 1.56. So again, the first things that we should do are set up my chemical equation. Next thing I should do is set up my equilibrium expression. My equilibrium expression, again, is products over reactants. In this case, I'm actually given my equilibrium expression. 1.56 is my equilibrium expression, my Kc, my equilibrium constant. Now, the initial information we were given is that we were given some amount of carbon monoxide and some amount of water. We were given 0.250 moles of carbon monoxide, 0.250 moles of water. In 0.125 liters, again 125 milliliters, we can convert that to liters, and I end with a certain concentration of carbon monoxide and water, 2.00 molarity each, 2.00 molarity each, and again I assume initially that I have none of this and none of that. So now that we've calculated the initial concentrations, what we should try to think of is what are my changes going to be? If I start with something over here and I don't start with anything over here, there is no way for me to go in the reverse direction. The only thing that I can do is go forward. So thinking about that then, my change on this side must be minus x. Now minus 1x because my coefficient is 1. Again, for water, my change will be minus x as well, minus 1x because my coefficient is 1. All of my coefficients here are 1, so I should have minus x and plus 1x all the way across the board. Now, if I had minus x and minus x, on this side I will have plus x and plus x. So, at equilibrium, what I can say now is that my concentration of carbon monoxide is 2.00 minus x. Concentration of water is 2.00 minus x. Concentration of CO2 at equilibrium is x. Concentration of hydrogen at equilibrium is x. So, now that I'm looking at this, the question was asking me for my equilibrium concentrations, as in my equilibrium composition. How much of this do I have at equilibrium? How much of that do I have at equilibrium? And how much of these do I have at equilibrium? So the only way to figure that out is to look at my equilibrium expression here. I have that my equilibrium constant is equal to 1.56, and these are all my equilibrium concentrations. This will tell me about my composition at equilibrium. So right now, I can set this equation up and say 1.56 is equal to, on top of my concentration of carbon dioxide at equilibrium, x, times my concentration of hydrogen at equilibrium, which again is x. So x squared goes on top. On the bottom, I have concentration of carbon monoxide, which I found to be 2.00 minus x, and my concentration of water, which again is 2.00 minus x. So I have 2.00 minus x squared on the bottom, x squared on top. When I solve this whole thing out, what I end up with is 1.56 is equal to x squared over 4.00 minus 4x. Sorry, I'm looking at the work on the paper. You can follow along in your lecture notes as well. Plus x squared. So 1.56 is equal to x squared over 4 minus 4x plus x squared. When I solve this whole thing out, again, this is just basic algebra, guys, so I have 6.24 minus 6.24x plus 1.56x squared is equal to x squared. Doing the algebra, so follow along on the algebra. I now solve for this in an ax squared, so in an ax squared plus bx plus c is equal to 0. I solve for this because we're going to have to use my quadratic equation. So in this manner, this equation up here, I solve for ax squared plus bx plus c equals 0, and I end up with 0.56x squared minus 6.24x plus 6.24 is equal to 0. Again, that's taking this equation up here and putting it in the form of ax squared plus bx plus c equals 0. So, now that I have this formula, I can use the equation x is equal to negative b plus or minus the square root of 4ac, nope, it's b squared. This is why I'll be giving you guys the quadratic formula on the exam. So b minus b squared minus 4ac all over 2a, yeah? Beautiful. All right, using this formula, again, my b is right here. My b is equal to negative 6.24. A is equal to what's in front of my x, which would be 0.56, and C would be equal to a positive 6.24. Again, A, B, and C, just in case you needed a refresher on the quadratic equation. My apologies for having to shift this. There we go. Sorry for the glare. Again, this is in your notes as well. The quadratic equation is in your notes in Chapter 17 lecture slides. When I solve for x, I should get two answers. The correct one will be the positive value. The positive value I should get from this is that x is equal to 1.11 molarity. So, 1.11 molarity, that was really exciting that we had to do the quadratic formula and it gave us this number. So now that we've found x, that x is equal to my concentration of H2 at equilibrium. So x is equal to 1.11 molarity. That's one thing solved. That was one of the pieces of my mixture, and that's my concentration of H2. That is also the concentration of CO2. 1.11 molarity is my concentration of CO2 at equilibrium. But now I need to figure out my concentrations of carbon monoxide and water. My concentrations of carbon monoxide and water would be 2.00 minus x, and again, x is my 1.11 molarity, so I find that my concentration down here would be something like 0.89 molarity. And same with my concentration of carbon monoxide at equilibrium, 0.89 molarity. Again, that 2.00 minus 1.11 molarity. So, we're going to do one more thing before Monday, hopefully, and that is the x is small approximation, where instead of doing this quadratic equation, which was absolutely painful, we're going to assume x is small, and I'll show you guys that soon.